Hello class, this is from Mr. Claxon's Algebra 2 class. We're on page 192, number 27. We have a linear programming problem here, and I have an objective function up here which we'll come back to later, followed by some constraints listed in blue here. In order to graph the constraints, to find the feasible region, I need to first make each constraint, each inequality, able to be graphed. I've done that by solving for y. I subtracted x on each side and then divided by 2. Notice how I did not need to flip the inequality because I did not divide by a negative. I end up getting y is greater than or equal to negative 1/2 x plus 1 1/2. I'm going to go ahead and grab the green pen over here so I can show you how I graphed that. Went up 1 1/2 on the y-axis, plotted a point, followed my slope, went down 1, right 2, then I went up 1, left 2, and up 1, left 2 again. Now I'm going to attempt to draw a line right over top of those points as accurate as possible. I'm going to go ahead and take it here, and it doesn't look half bad. I really don't even need to go below the x-axis. You'll see why later. I'm just going to see if I can't just highlight that line. So we're going to just highlight that line. I'm going to use the mouse here. I'm going to cheat a little bit. Use the mouse, and that looks pretty good. And I would like to go ahead and put end caps on that. Let's acknowledge the fact that it is a line. It does want to extend forever. Alright, next we have, I solved for y right here in 3x plus 4y is greater than or equal to 8. Go ahead and pause. Alright, we're going to go ahead and pick up right where we left off here with that nice magenta color. And they're coming back on the announcements, but we're just going to power right through it.
Those students riding the Spirit Bus tonight to Daysville, just a reminder that the bus will be leaving at 6 o'clock on 3rd Street. Also, a reminder, if you've not yet bought your Sweet 16 volleyball t-shirt, you may buy that before getting on the bus. They will be selling them prior to...
Okay, I have graphed that line there in magenta. Y, actually, I've graphed the inequality. Almost graphed the inequality. I haven't shaded yet. I just get my lines in there first. Then I go back and take care of the shading. So let's go ahead and graph the next two lines. X is greater than or equal to 0. X is greater than or equal to 0. So let's go down here and grab the red. X is greater than or equal to 0. It means every x value on that line is 0. If that was going to be x equals 0, then every x value on that line would be, hold on. Okay, every x value on that line would be 0. So the only line that satisfies that, every x value is 0, I do not move left or right at all, is the y-axis. It's kind of confusing. So I'm going to go ahead and plot that line right there on the y-axis. Okay? Now I don't need to go below the x-axis, and I know I'm going to be shading to the right. Okay, the next line, y is greater than or equal to 0, we'll go ahead and graph that in blue. I know that if that were y equals 0, if that were the line y equals 0, then every single y value on that line would be 0. The only line that satisfies that is the x-axis. I do not need to draw left of the y-axis because I know I'm shading to the right of it. So I'm just going to go ahead and draw the line that I need. And I know that I'm going to be shading up or greater than for that particular line. I go back to these two. Remember, I didn't want to worry about it earlier. Go back to my green line over here. Y is greater than negative x over 2 plus 1 1/2. I know I'm shading above that one and above the magenta line. So I'm shading above here. Oh, but I'm not shading down there. I'm shading up here. So really the green line doesn't even matter. if you look at it, other than the fact that it intersects the x-axis right there. The green line does not even matter. Look at that magenta line. I'm shading above it, greater than, so I know I'm shading above it there. Now I'm going to go ahead and use orange to represent that feasible region. Very important that you understand here. I'm going to go ahead and outline my feasible region. Before, I could use black as well. So I'm going to outline. I know it comes down. It turns right there. There's a vertex. And there's another vertex. So there are only two I only see two vertices there. I'll go ahead and plot them in black. Two vertices. I see one right here, and that would be at the point 0, 2. It's where this line right here goes through the y-axis. We've already determined that. And then down here, it appears as though those two lines intersect at the point 3, 0. 3, 0. So we're going to go ahead and test that. It actually, I think it's more like 2.5, or 2, and then up a half. We can check that. It's a more advanced, actually it's less advanced. You would know how to solve those two equations if they were equations.